Hey everybody, my name is Jensen. I'm one of the TAs for your class, and I'm also a senior chemical engineering major. And I just wanted to make a quick video kind of going over a little bit about Matlab, going over one of your homework problems, because I know this is definitely a new programming language for most of you, and it's one that you're going to be using for the majority of the rest of your chemical engineering classes. And I know you still have a couple assignments left in 2103, and you'll be using it a bunch during junior year. So I just wanted to do a quick video that'll kind of go over some of the basics and hopefully help you guys get a hand on everything. But the best way I found of just learning any programming language is just kind of trial and error and just, practicing with it over and over again. So I have no doubt that all you guys will be able to get a hand with it. But so first, just getting into Matlab. So you're going to open up Matlab, and mine may look a little different than you, but than what yours looks like. But the first thing you'll see here is the command window. So this is where you're able to type just any amount of code. So you could just type, simple assignment statements like x equals 10, and it's going to execute this line of code instantly. So I find that this is a really good place for just testing quick things in your code, or possibly seeing how certain control statements, possibly how certain like for loops or while loops will work. But this isn't going to be where you actually write code for a homework assignment or a project. As you guys know, you're going to have to click new script, and then here is where you're able to write all of the code, define any functions, and all of that good stuff. And so just some basics of MATLAB that you're going to be using for the rest of your chemical engineering curriculum is it's important to know how to write vectors, which I'm sure you guys already have some experience with it. So if I just wanted to create a simple row vector, then in the command window, I'm going to type v, which I guess I'm just having stand for vector, and then it's going to be a bracket, and then whatever numbers that you want, followed by a space, not a comma, and then you want to close your brackets, and then this is going to get you just a simple row vector of whatever numbers you typed. And then say that you wanted this exact same vector, but you didn't want it as a row vector, you wanted it as a column vector. So then the syntax for that is just you want to probably make another assignment statement, so then you can store this in a new variable. So I'm going to store this new column vector in a variable called column. And so I'm going to say column equals v, which is our row vector, and then I'm going to put an apostrophe, which basically says change this row vector into a column vector. And then after I hit enter, you can see that I now have a variable named column, and it is a column vector of the same numbers. And so this is just a quick way to make very specific vectors of numbers. But say you just wanted to make one of all zeros or possibly all ones, then the syntax for that is going to be, so A equals zeros, 1, comma 6. So that is going to create just a row vector with 6 zeros already input. So the way that this syntax works is we have what we want to store as the variable, so A, and then equals zeros, which just tells it that all the entries of the vector or the matrix are going to be 0. 1, 6 stands for, the 1 stands for how many rows that we are going to have. So 1 row, and then 6 stands for how many columns that we are going to have. So we have 6 different columns. And then if we wanted to change that, we could do A equals zeros to 6. So now we have 2 rows and still 6 columns. And so this is going to be useful when you need to start initializing vectors or matrices and inputting certain information in these. I know that for chemical engineering analysis, which you take fall of junior year, you're going to need to have a good understanding of how this works, because you're going to be using it a lot throughout the entire class. That whole class is basically taught in Matlab. You're going to have weekly homework assignments on it, but don't worry, you're going to be prepared for it. Usually, Dr. Stuber, if he's still teaching it, will work up with you so that you have a good handle on everything. And after that class, you'll have a very strong understanding of how Matlab works. So then a couple other things that I want to go over are, say you've been typing a bunch of stuff in your command window, or you've been running your program and you have a bunch of different variables or matrices or whatever in your command window, and it gets a little messy. The command to clear this command window is just CLC, hit enter. And so that clears your command window. And so now it looks all nice and clean. But all of these variables that you created, they didn't go away. See, when I type A, I still have that 2x6 matrix. If I do V, I still have that row vector. All of these variables are still stored in something in MATLAB called your workspace, which you can see down here in the bottom left. And your workspace is basically, after you run a program or type anything in your command window, it stores all of the variables for you to see. And it's actually extremely useful because sometimes when you're trying to debug or just understand what's going on, you want to see what values are stored with every variable, and you can see that here in your workspace. But say if you're just testing code and you want to try and you just want to clear that workspace, then the command to do that is just clear. And see, after I typed clear and enter, the workspace was cleared of all the previously stored variables. Now if I type A and enter, it's going to tell me it's an undefined function or variable because there's nothing stored in it. And so that's really useful when, testing your programs or trying to use a certain variable again, but with a different value. And so one other quick thing I wanted to go over while in the command window is, say you're writing a while loop. So let's just say x equals 25, and then while x is less than 20 or less than 30, I equals 1 plus 1. Is that gonna work? So that works, but see, it doesn't show very well. But this while loop is still running because I never had x incrementing. So I just want to show if you're running a program and you click run when you do your script and you want to try and exit the program because obviously something isn't working, then the command to do that is Control C, and it'll just exit that program, and then you'll be able to try to fix your error, and you'll be able to run it again. See here, now I can type in the command window again, and everything is okay. And so I know it's hard if you don't have experience to try and remember all of this. So a very good resource to use is the let me see. So as I was saying, a very good resource to use is the Matlab documentation on MathWorks. So if you just Google, Matlab documentation, then the first link will most likely be the MathWorks link. And here you're able to see basically everything there is about Matlab. You just click on Matlab, you can do getting started, let's just click getting started. And then here you're able to see, matrices and arrays, and you're able to see all of the example code and everything written out in words about the different functions of Matlab and what you're able to do. So whenever you're having a problem, I would just suggest Googling, the documentation, and then you can literally just figure out basically everything you need to know from this MathWorks page. I know when I'm doing anything in MATLAB, I use it all the time, and it's definitely extremely useful. And so now that we have all of that down, next I just want to go over an example. So I'm just going to go over the homework 9 assignment. So for your convenience, I've pulled it up here. So when looking at this problem, the first thing I'm thinking about is, okay, we have a pool with these dimensions, and we also have a flow rate. And we're asked to plot the depth of the water in the pool as a function of time from when you started filling it until 6 hours later. So a lot of the problems that you're going to have when you're using MATLAB are going to be graphing problems, because MATLAB is really good at, graphing and integrating and all of that good stuff. So the first thing I'm going to do when trying to solve a problem like this is, I know we need to plot the depth and against the time. So I'm going to try and find an equation for the depth of the pool, not even taking the time aspect into account. So I'm just thinking, well, length times width times depth equals volume. Maybe I need to solve this for depth. So doing that, I'm going to get volume divided by the length times the width. And so how am I going to get the volume from that? Well, I have a flow rate, and so that is going to be in, I believe the problem statement has it in gallons per minute. So yeah, our flow rate is gallons per minute. So in order to get the volume, what am I going to do? I'm going to multiply that flow rate by the time. And so that's how you kind of get your equation that you're going to use to solve this problem. So just walking through this code, I think it'll make it a little more clear than that explanation. So first thing I do when writing code, this is a habit that I picked up from analysis in junior year, is the first thing you do is you create a function that's basically just your name and whatever homework that you're working on. And a good thing to do is to comment extensively, not only in your code, but also your functions. So commenting what each function does. So here I have a comment that explains what this function, Bassett homework 9, does. It's going to call the function for solving homework 9. I have the author, so the author is me. And then what I put in this first function usually is the CLC command, which is going to clear the command window, and then also clear, which clears the workspace, just in case if the TAs need to run your code and check they don't have a bunch of previous variables in when running your code, it'll just clear everything. And then also within this function, I have something called depth, which is defined below. And this function depth is what's going to be the function that actually solves the problem. So here is where I want to define my variables and also basically solve the equation that I just mentioned. So here we have our length, we have the width, and then we also have the volumetric flow rate. So it was in 10 gallons per minute. And then here, this 0.1336 basically is just converting it to cubic feet, because this is the unit that our length and our width are in. And so now we have all of the constants that were given to us in our problem. So now I know, well, I just need to solve my equation, and since I'm graphing it against time, I know that this is going to be an iterative process where I'm going to have to solve my equation, you know, several different times. And this is also very typical of most of the problems that you are going to solve. Once you have figured out your equation, then you just need to think about, okay, what is the range that I need to solve this equation over, and how many times am I going to have to solve it? So knowing this, I'm like, okay, I know I'm going to have to iterate this, so let's set up a counter variable. So typically my counter variable is just called I. It's just kind of a convention sometimes. That's just the one I use. You can literally use any variable that you want. And then here is where this for loop is where I'm actually solving for the depth of the pool. So here I'm going for time from 1 to 360. So this is going to iterate from the very first minute to the 360th minute, which is the 6 hours that was mentioned in the problem statement. So then all within this for loop, I'm going to do I equals I plus 1, which is going to increment my counter. So on the first iteration, I'm going to have I equals 1. And then here on line 18 is when I am actually solving the problem. So I have the equation that I talked about previously, where I solved for the depth. So I have depth equals Q times T, Q being the volumetric flow rate from earlier in the problem, and then multiplied by the time to get the volume. So this first term, Q times T, is going to give us the volume of the pool at that specific minute, and then divided by the length times the width, which is also defined on lines 10 and 11. So basically this line of code right here is going to calculate the depth of the pool at any time t. And so then I know, again, since it's an iterative process, and I know I'm going to be needing to graph it. In order to graph, you're going to need two vectors. And so I store every single time. So the first minute, the second minute, the third minute, I store in a vector called time. So this is what line 19 is doing. It's saying create a vector called time, and at every location in it, so at time at location I, which is going to be 1, and then it's going to go again, iterate again, and it's going to be 2. So it's going to say time at location 1, 2, 3, 4, 5 is just going to equal the little t variable, which is basically the same value. It's going to be 1, 2, 3, 4. And this is just so I have a vector of all of the times from 1 to 360. There are several different ways that you are able to do it, but this is just the way that I coded it in. And so then after I have this time vector, don't forget that you always want to, sanity check your results as mentioned in the problem, and just always check over the problem statement again. So it gives strict dimensions for the pool. It says it's 14 feet long, it's 8 feet wide, and it's 3 feet deep. So let me see. When we are solving for the depth, we always want to make sure that it is less than 3 feet, because maybe over this course of 6 hours, with the flow rate that we have, it would actually go over the 3 feet that's given in the dimensions, and you're basically just overfilling the pool at that point. So within this for loop, I want to check if the depth is less than 3 feet. And so this is saying, okay, check this calculation that I made in line 18. If this calculation is less than 3, which is the depth that is given, then store this value into another vector. So I called this dvec, which just kind of stands for the depth vector. And this again is very similar to the to line 19, where we stored everything in a time variable. I'm sure you guys already have some experience with this. So dvec at location I, which is again the counter, is going to equal the depth, which is the scalar value that was calculated in line 18. So basically these two lines are just checking to make sure the depth is below 3 feet, and then storing all of those values into a vector so that at the end of my code, I'll be able to graph it all. So again, if depth is less than 3, store this variable in a vector. Else, so otherwise, if the depth is calculated to be more than 3, then we know that the pool would overfill, and we want to make sure that it always stays at 3 feet. So else, if the depth is calculated to be more than 3, just store 3 feet into the vector that we have. So this will make sure that after the 6 hours, if the depth is ever increasing to a value of more than 3 feet, we're just storing it at 3, because we know realistically when filling the pool, that's when we stop. But we want to just see what this graph looks like over the course of 6 hours. And then here I end my for loop, and then I end my if statement with the end on line 25, and then with the end on line 27, I'm going to end my for loop. And so these last lines on the code are just generating my plot. So I'm on line 34, it says plot time in dvec. And this is why we needed to store everything in vectors, because when using the plot function, unless you have two vectors of equal sizes, you're going to run into an error. And so I want to make sure that when using the plot function, I have two vectors and they're both the same size. And then the lines under this are basically just going to create the graph and make it, title the axes, make it look a little nicer. Y-lim is just going to be so it only has the y-axis is only going from 0 to 4. And so then when I run this code, I'm going to get a graph of the time in minutes against the depth of the pool in feet. I have the title, it goes from 0 to 360, and you can see how the depth is increasing over time. So that was just a quick review of this one homework problem and how I went about solving it. A couple of tips. I always like to try to comment as much as I can throughout my code, and how to comment is just you just type the %sign and then create your own comment. And you can just type whatever you want, and it's a really good way to just kind of keep your thoughts in place try to keep your units in place and explain what you are doing, so not only you understand your code, but also whoever is grading it can also understand your code. And then other important things to know when writing code, you always want to use semicolons after the majority of the lines that you type. Otherwise, MATLAB without a semicolon is going to print out whatever that line is. So it's going to print out the execution of that line. So say here on my increment counter, I didn't put a semicolon. Now I take away the semicolon and MATLAB automatically will do a yellow underline. And this kind of is just alerting you and MATLAB that something might be up in this line. And so to see any of what these yellow underlines mean, you just go over to the right-hand side and kind of hover your mouse over the yellow strip. And it's going to say, okay, line 17, terminate statement with a semicolon to suppress output. And so this is just saying, unless you want this line to output every single time, make sure to put a semicolon. But I'm just going to, and then you put the semicolon, the yellow line goes away. I'm just going to take that away to quickly show what would happen. So now I take that semicolon away, I run my code, I still get my graph because everything is still being executed in my code. But now this line, if I go to my command window, is being executed 360 times because I didn't put a semicolon there to suppress the output. So sometimes this is really important and useful because you don't want your code to just be outputting everything. It'll slow it down. It'll make it so much more confusing to you. But also sometimes it's really helpful because maybe you want to see what is going on with your code at different points in time. So like down here, I commented some things out. So let's just say I wanted to see what exactly is in my D vector. So what is that? And then let's say I also wanted to see what is in, let's just do dvec. So let's just say I'm trying to debug my code. I don't know what values are being put into this vector function. I don't know if it's depth. I don't know if I'm calculating depth correctly. But let's just run the code and then we can see what is being put in it. So now we look at the command prompt and we can see, okay, well, this is obviously the time after the depth is at 3 because we know all these values are being stored. But let's go down to first. So here we're able to see early on what the depth of the pool is at each different minute. And ultimately, this seems to make a lot of sense. It's, not skyrocketing. It's not extremely low. And so if we did have any problems here in our depth vector, we would be able to see that pretty quickly. And so the semicolons and printing stuff out after functions is a really useful way I've found to debug my code, especially if I don't know what values are being input into a certain either variable or vector or a matrix. And then another quick thing I want to mention is there's another way to help debug your code. And this is with when you open the scripts, MATLAB has its own debugger. So let's say that I want to run a certain section of my code, but I want to stop it right at line 16. If I go over to line 16 and I click the little dash that's after, it'll put a gray circle there, and that's just going to tell MATLAB to run everything up until line 16. So I'll click run. It'll run everything up until line 16. And then if you go over to your command window and your workspace, you're able to see everything that MATLAB has calculated so far. So it ran all of the code up until line 16. these are the variables that we have created. We created an I, we created the length, the width, and the volumetric flow rate, as you can see above. So that all makes sense. And then if we want to quit debugging, we can just hit the quit function. If we want to continue running the code, we'll just click this continue button. But say we just want to run line by line to see what exactly Matlab is doing and what's going on in the code. We can hit this step. So now we can see Matlab stepped on and went to the next line of code and began running that line. So now we see, okay, it moved on, it's in the for loop, it's starting to increment. Any variables that are being created are here. And this is another good way to just try and debug your code and just get an understanding of what's going on. And so this was just kind of a quick review about Matlab, a quick review over the, I believe it was homework 9 Matlab question. If you guys think that this video was helpful or want more like it or just want another video for the current homework assignment, just let me know and I can work on getting that out to you guys. If you did watch this video, I would also appreciate it if you filled out the survey that goes along with it. And yeah, I hope you guys had a really awesome break. I hope this semester, even though it's extremely hectic and crazy, I hope it's still been going well for you guys. You've been enjoying chemical engineering, getting a good handle on Matlab. And yeah, I think that's all I have. If you have any other questions about chemical engineering, Matlab, you know, college in general, just feel free to reach out. Let me know. I'd be happy to help. And yeah, I hope you guys have a great rest of your semester.